Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to cover the rest of the problems of exercise 6.2. Earlier to this we have covered exercise 6.1 and first 5 problems of exercise 6.2. This is going to be the part 4 of progressions chapter. Today we are going to start with the 6th problem, which is already on the board. So let's get started. So here they are asking us to check whether minus 150 is a term of AP or not. Okay, so in order to figure out that either if 150 is a term or not, how do we solve this out? In the earlier video, the last video, part 3, I have mentioned that by looking at the question, by understanding it, you should be able to figure out the ways to solve it. So here one term is given and series is given, the arithmetic progression series is given. So from this we can extract the first term and common difference. And if I assume this as n, can I solve this? Yes. So that's how we can solve this problem. So let's get started. What is given? Given AP, what is it? 11, 8, 5, 2. From this what can we draw? A is equal to 11. D is equal to A2 minus A1 is equal to 8 minus 11, which is nothing but minus 3. So the common difference is minus 3. Now we need to figure out if minus 150 is a term of this series or not. So let us assume, let an is equal to minus 150. The nth term in the series be minus 150. If we can extract n out of this particular formula, then we are done. Okay, so a plus n minus 1 into d is equal to minus 150. So a is nothing but 11 plus n is something which we need to figure out, and 3 is d is minus 3 and minus 150. So 11, I am sending it the other side. Minus 3 into n minus 1 is equal to minus 150 minus 11 is going to be minus 161. And n minus 1, if I am going to send it the other side, minus 3. So minus 161 by minus 3. That way n is equal to 161 by 3 plus 1. Okay, if I solve this, this is going to be 3 5s are 15 plus 15, and this is going to be 11. So 3 3s are and again 2 comes out, so 3 6 are 18. So again 2 comes out and it goes on. So this is going to be 54.666. N is going to be 54.666. So far, in whatever the examples or whatever the topics, concepts we have learned, have we seen n as a fraction or a decimal value? No, isn't it? Because n cannot be fractional. You can say the third term is this, the fourth term is this in an arithmetic progression, but not 3.2's term is this, 5.6 term is this. We cannot say that because we do not allow fractions into this. We just allow only numbers, natural numbers into this particular part. So here therefore n cannot be a decimal value or fraction. You can write it as this or this. Hence, minus 150 cannot be a term of given AP. Alright, that's about problem number 6. Let's look at the next problem, problem number 7. Here, what is given for us? Let me read it out for you. Find the 31st term of an AP. We are to figure out the 31st term of AP, whose 11th term is given as 38 and 16th term is given as 73. Okay, so what is given for us? 11th term is given. A11 is equal to 38. And what else is given for us? A16 is equal to 73. A11 is given. So can we write it in the form of a plus n minus 1 into d? Yes. A plus 11 minus 1 into D is equal to 38. A plus 16 minus 1 into D is equal to 73. A plus 10D is equal to 38. A plus 15D is equal to 73. Let me name them as 1 and 2. And what are we supposed to figure out? A 31, 31st term is what we need to figure out. How do we solve 1 and 2? I'm going to subtract 2 from 1. Okay. A plus 10D is equal to 38. A plus 15D is equal to 73. Alright. Now, as I'm doing a subtraction, the signs get changed. A gets cancelled. Minus 15 plus 10 is minus 5D is equal to 73. This is nothing but 13 minus 8 is going to be 5. And 6 minus 3 is going to be, and the bigger number sign comes here. So D is equal to 35 by 5 is 7. Now that I got D, how can I figure out A? Substituting D in either of the equations. So I'm substituting it over here in 1. So A plus 7 into 10 is equal to 38. A is equal to 38 minus 70. So A is equal to 70 and 38 is, this is going to be minus 32. The subtraction is 32, and as we get the bigger number sign, this is going to be minus 32. So when we are solving for A 31, this becomes A plus 31 minus 1 into D, which is nothing but minus 32 plus 30 into D is 7. Minus 32 plus 210. Now we do the subtraction. Minus 32. 10 minus 2 is 8. 10 minus 3 is 7. And this is going to be 178. So A31 is going to be 178. Alright, that is about problem number 7. Let's look at the next problem. So here we have the ninth problem listed on the board, which says the 17th term of an AP exceeds its 10th term. The 17th term exceeds its 10th term by 7, and we are to figure out find the common difference. Okay, CD, I just noted it as short form. So what is given for us? Given the 17th term exceeds 10th term by 7. Meaning, what is the 17th term? How do we write as in notation? A17 exceeds, so this is bigger than the 10th term by, the difference between them is nothing but 7. That is what is given for us. Now we are to figure out the common difference. So let us expand this formula. A plus 17 minus 1 into D minus A plus 10 minus 1 into D is equal to 7. Why? Since an is equal to a plus n minus 1 into d. This is the formula we need. Isn't it? Okay. This is an extra press. Alright. So a plus 16d is equal to, minus a plus 9d is equal to 7. Now let me take this minus inside. A plus 16d minus a minus 9d is equal to 7. A gets cancelled. 16 minus 9 is nothing but 7d is equal to 7. 7 gets cancelled. So d becomes 1. Therefore, common difference is equal to, what is the common difference? 1. Okay, that's about problem number 9. Let's look at problem number 10. In problem number 10, let me read it out for you. Two APs have same common difference. There are two APs with same common difference. The difference between their 100th terms is 100. What is the difference between their 1000th terms? Okay, now that he said that there are two APs. So, let the two APs be. The first one would be A1, A2, A3 and so on, A100 and so on, A1000. Okay. and it will be B1, B2, B3 and so on, B100 and so on, B1000. Okay, what is given? The difference between their hundredth terms. Hundredth term in the first series is A100. Hundredth term in the second series is B100. So what is given? Given the difference between their hundredth terms is 100, which means A100 minus B100 is equal to 100, isn't it? Also given, similarly given, what is given? Two APs have same common difference. Two APs have same common difference. What is that? D. Okay. How do we take the common difference? By which notation? That is nothing but D. So A plus 100 minus 1 into D minus B plus 100 minus 1 into D is equal to 100. A plus 99D minus B plus 99D is equal to 100. Alright, A plus 99D minus B minus 99D is equal to 100. That means A minus B is equal to 100 as 99D gets cancelled. Okay, now that we got an equation from what he has given. Now we are to figure out the difference between their thousandth terms. So, difference between thousandth terms is equal to A1000 minus B1000. Now expand the formula. A plus 1000 minus 1 into D minus B plus 1000 minus 1 into D. Now I am performing the subtraction and also taking this minus inside. That way this becomes A plus 999D minus B minus 999D. 9D, 9D, 999Ds gets cancelled. Now we have A minus B. What is A minus B from equation 1? Nothing but 100. Therefore, A1000 minus B1000 is also equal to 100. That is nothing but the difference between thousandth terms is equal to 100. Alright, that's about problem number 10. Let's look at the next problem. So here we have the 11th problem already written on the board, which says how many 3-digit numbers are divisible by 7. Okay, for this thing, if you know 7th table, well and good. If not, you need to calculate and figure out what is the first 3-digit number that is divisible by 7. As per my knowledge, 15 sevens are 105 is the first 3-digit number that is divisible by 7. Okay, even before to that 14 sevens is 98. So that's not a 3-digit number. So let us get started with 105. Okay. What is given for us? 3-digit numbers divisible by 7. So what is the first number I told you? 105. Why did I take 105? Even before to that, the 7 multiplies 98, which is not a 3-digit number. And if we go on, the last number, the last 3-digit number is 999, right? Even before 999, the number which is divisible by 7 is 994. I am not just telling you for this sake, your problem's sake. I have solved this in my entire book, like from 999. Is it divisible by 7? No. 998. Is it divisible by 7? No. And finally, I ended up 994 is the last digit which is divisible by 7. For this particular problem, you have to do this exercise by yourself. Since I have already done this, I am just writing it as 994. Okay, 994 is the last number. Okay, after 15 sevens, we also have to write the next one, right? The second term. 7 6 are 42, 7 1s are 7, 11. Okay, 1 1 2 is the second term. Now, from this series, what can we figure out? The first term, 105. The common difference, 112 minus 105 is nothing but 7. And how many three-digit numbers are divisible by 7 is the question asked. So, if I say nth term of this series is 994, can I get n which exactly says how many numbers are there in between 105 and 994? So, we are going to solve this problem by using that particular approach, wherein I am going to consider the nth term of this particular arithmetic expression as 994. Okay, that means a plus n minus 1 into d is equal to 994. A is 105. N minus 1 into d. D is 7, right? 994. So, n minus 1 into 7 is equal to 994 minus 105. Okay, if you do this subtraction, we'll have n minus 1 into 7. 14 minus 5 is 9. And this is going to be 8. 9 minus 1 is 7. N minus 1 is equal to 7, 8, 9 by 7. 7 ones are 7. 7 ones are 7. Alright. 9 minus 1, sorry, this is 8, 8, 9. 7 ones are 7 and this is 18. 7 twos are 14. So this is 127. N minus 1 is equal to 127. N is equal to 127 plus 1, which will give us the result of 128. So how many three-digit numbers are divisible by 7? 128 numbers are divisible by 7. Therefore, 128 numbers are, what numbers these are? Three-digit numbers. Please mention it. 128 three-digit numbers are divisible by 7. Alright, that's about problem number 11. Let's take a look at problem number 13. Each and every problem in this particular exercise is a different problem. You need to figure out the formation of this problem. The sentence formation is quite different, but it is the same approach that we are going to follow in each and every problem. And every problem we are going to use the same formula, which is our nth term of a arithmetic expression. Okay, but it's just the formation is different. So here, for what value of n are the nth terms of two APs? The first AP is this and the second AP is this, are equal. So what is given for us? Given two APs are given, 63, 65, 67 and so on. For this, A is equal to 63, D is equal to 65 minus 63, which is nothing but 2. For the second series again, 3, 10, 17 and so on. A is equal to 3, D is equal to 10 minus 3 is equal to 7. Now, for what value of n are the nth terms are equal, meaning nth term of this particular series is equal to nth term of this particular series. Nothing but the arithmetic expression. So, an of first AP is equal to an of second AP. Meaning a plus n minus 1 into d is equal to a plus n minus 1 into d. But here for the first series, this is 63 plus n minus 1 into 2 is equal to 3 plus n minus 1 into 7. 63 plus 2n minus 2 is equal to 3 plus 7n minus 7. 63 minus 2 is 61 plus 2n is equal to 3 minus 7 is 4. 7n minus 4. Now, I'm taking this 2n the other side. That becomes 7n minus 2n is equal to minus 4. 7n minus 2. Oh, sorry. This is going to be 61 plus 4. This comes this side, this goes that side. That way 5n is equal to 65. N is equal to 5 ones are 5 3s are. Therefore, for the value of 13, the nth term of this particular series and that particular AP, both the values becomes equal. Therefore, for the value of 13, the nth terms of both the series are equal. All right, that's about problem number 13. Let's have a look at the next problem. So here we have the 17th problem, which is written on the board. Like it is exactly the same example that I have given you to make you understand the concept, wherein Subbarao's salary is 5,000 per month with an increment of 200 each year. In which year did his salary reach 7,000? What actually happened is, I have given the explanation for this particular problem without starting recording. So I'm doing it again. So given salary is equal to 5,000 and increment is equal to 200. Now by assuming the nth term to be 7,000, we can simplify this like a plus n minus 1 into d is equal to 7,000. This is exactly the use case that I have told you in the concept. And by simplification, you will get n is equal to 11. After 11 years, his salary is going to reach 7,000. All right. So if you feel that the content is worth enough and you are able to understand the concept, please do circulate it to your 10th class friends or any of your relatives studying in 10th class. And please do like, share and subscribe to Anantha Lakshmi Academy. And thank you for watching.